Welcome to James's Physics 101. Today we explore the bridge between the microscopic world and the laws of thermodynamics. Trillions of atoms moving in total chaos, yet they create a world of perfect, predictable order. This is the paradox of statistical mechanics. I'm Ludwig Boltzmann. In previous lessons, we saw how energy and entropy rule the universe. But how do the random kicks of individual atoms lead to these ironclad laws? That was my brilliant gamble. In this lesson, we will define microstates and macrostates, uncover the law of large numbers, and see how probability creates the arrow of time. To understand the whole, we must look at the parts. A microstate is a specific snapshot of every single atom, their exact positions and velocities at one moment. Think of it as a detailed map. With trillions of atoms, there are more possible microstates than there are grains of sand on every beach on Earth. But we don't feel individual atoms. We feel the macrostate, the big picture properties like temperature, pressure, and volume. These are what we actually measure. Imagine flipping 4 coins. Getting 4 heads is one microstate, but getting 2 heads and 2 tails? There are 6 different ways that can happen. Nature doesn't have a preference for order or messiness. It simply favors the macrostate that has the most possible microstates. The most probable state is what we see. As we scale from 4 coins to 1 trillion atoms, the probability of seeing anything other than the average state becomes practically zero. Order emerges from sheer numbers. This is the law of large numbers. It's why all the air in your room doesn't suddenly rush into one corner, leaving you in a vacuum. It's possible, but statistically, it will never happen. The odds of every atom picking the same corner are so low that the universe would end billions of times over before it occurred even once. Order is just the most likely chaos. I condensed this entire concept into one simple, elegant equation. It connects entropy directly to the number of ways a system can be arranged. S equals K log W. Entropy is the measure of hidden information, the number of microscopic arrangements that look identical to us on the outside. This was my gamble, that we don't need to track every atom to predict the gas. We only need the statistics. The chaos of the few becomes the certainty of the many. Thermodynamics isn't a set of rigid rules. It's a set of overwhelming probabilities. It's the most successful bridge in the history of science. Entropy isn't just a measure of messiness. It's a count of possibilities. The universe moves toward the state that has the most ways to exist. That is, the arrow of time. To recap, microstates are the hidden details. Macrostates are the visible effects. Sheer numbers create predictability. And entropy is the count of hidden microstates. Next time, we take these laws to their ultimate conclusion, the heat death and the final fate of our universe. I'll see you there. Thanks for watching. Don't forget to check out the full playlist to master the chaos. Subscribe to James's Physics 101 for more deep dives into the universe.